Something to lighten it. We got a method GPA requirements. Make sure you read through that email and see, follow the instructions. The deadline to apply for that on our site is October 15th. Even in Lightenberg, if you have any questions. Air Force recruiter, set up tomorrow during lunch. Get busy lunch tomorrow. Thursday, September 30th, you can stop by and visit with the Air Force recruiter if you're interested in joining the Air Force. Again, reminder, end of the day tomorrow, end of the first quarter midterm.
Fourth quarter.
We have all your items turned in.
Sign me up.
Weekend request.
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Can I mention right now first? The sunrise on your face in there.
You got this done?
No.
Do this then, Ro. That way you have attended to your responsibilities. Is that function big enough? Everyone can see 2x to the negative fourth? Anyone still going? Okay. So, some are still jammed with the calculators. 108. Meh. Ballpark, right? I know that I'm going to be at 1, 2. But after that, it's just increasingly small and small and small and small. At the very least, we need to have those 2 points because those are integers. The big part of it is, once you got it graphed, can you tell me all the stuff? Domain. Well, here. Maybe it helps if we write it like that. Domain. Who's not allowed to the party? Okay, so we're going to have negative infinity to 0, can't touch a span, and out. 0 to infinity. Range. Parenthesis or bracket? Parenthesis, because I can't divide by 0. X and Y intercepts. If 0 is excluded from both domain and range, that means no Bino. End behavior. I'm going to write limit of my function as x approaches. You can write them separately, or because they go to the same place, plus or minus infinity, is 0. If I keep dividing by a larger and larger and larger and larger number, it's eventually going to be worth nothing. Okay? If we, I don't know, chuck Lars up in the air and decide to fruit ninja him, but you do that forever, well, it's not eventually there's no more Lars, there's just Lars soup. Okay. Yeah, you get fractions of pennies. Fractions of pennies. Y'all know that when you calculate interest and stuff, there's always a part of a penny. And that percentage usually gets rounded off in favor of the bank that's charging you. So they just keep it. But you can't take out the exact amount. That's a fraction of a penny, but they'll charge you the fraction of a penny. So they do that a billion customers or a billion transactions, and they steal your money. Continuity. Right. There's infinite discontinuity, and you say where. Intervals of increase and decrease. It is, as I go left to right, increasing this way and decreasing this way. So increase, going to be from negative infinity to 0. Decrease from 0 to infinity. Symmetry wasn't always put on these last time, but what's it symmetric to? Okay. How do I prove that? Negate x. And because it's to the fourth, it's just going to come out positive anyway, so that's how you prove that it's symmetric. So, here's what we're going to do. Now, naturally, there's a lot of stuff here, and you can't have that many points. So, as we talk about rounding, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for did you have the 1, 2, negative 1, 2, and did you have the correct butt crack graph? Okay, 10 total aspects, still out of 5, round down. So if you got one thing wrong, it's a 4 out of 5, not a 4.5 out of 5. Okay? If you got 2 wrong, it's still a 4 out of 5. Okay? Or 0.5 out of 5 on one thing over the course of the semester in a category that's only worth 10% of the grade regardless is infinitesimally small, which is redundant. Huh. So, any question? Infinitesimal is infinitesimal, infinitely small. Like the word infinitesimal means infinitely small. So when I say infinitesimally small, that's infinitesimally small, small. Yeah. It's like the whole Mr. Sir thing again. Hey, you go away. That's not you. That's you. Talk to me, Goose. Was that the one you were asking that I didn't answer until 5:45 this morning? Okay. Next page. There we go. Okay. They're all polynomials. Polynomials. They're all monomials. Monomials are all going to have the form y equals ax to the n. Frank, why? Why? Why are you like this? There we go. Next up, out of the different types of monomials we talked about, we have just a straight monomial like this. We have a y is a, stop that, a over x to the n like this as a rational function. We also have y is the nth root of x like this, which we didn't get to, which is why I gave you this one instead of this one. It's a rational function, right? It has the split thing. So I know it looks like this. Now, if I remember all the stuff about rational functions, I know technically it's a over b x minus h plus k like that, and then to the nth power. Because it has horizontal and vertical asymptote at 0, 0, I know that this is 0 and this is 0. So basically it's going to be this instead, because monomial, right? So y is a over x to the n. The only way I'm going to find a is by determining stretch or compression. Normally, I would go over 1, up 1. But I went over 1, up 1, 2, 3, 4. So a is 4. Now the question is, what is n? Is it the first, second, third, fourth? Because they're opposite, I know it's odd, right? Ours was, our daily quiz was x to the negative fourth. That had the butt crack graph. When they're even, it looks like a butt crack. When they're odd, they're separate. So I know it's going to be odd. I'm not sure if that's to the first, to the third, to the fifth. That's where those coordinates come in handy. They're x's and y's. Plug them in and figure out what it is. I should be able to say 2 is 4 over 2 to the n to determine what n is. Well, it's got to be in the first, right? 2 to the what power? 4 divided by 2 is 2. So I know this is 4 over x. And that's it. Well, remember we did this with another graph where to find the stretch or compression, you take what it did over what it should have done. It's supposed to go over 1 up 1. Any monomial, right? Because 1 to the 3rd, 1 to the 4th, 1 to the 28th, it's always 1. So if it goes over 1 and up 4, I know that there was a vertical stretch by 4 because it went 4 times faster than it should have. Why you gotta cut it off right there? Huh? Why you gotta be like that? And that was the only question that anyone asked. So, utters besides that. Okay. So here's what I want. I want to take care of the radical stuff, and regardless of how far we get, if we finish our radical stuff with a half hour left, I'm just going to cut it off there because we got a quiz tomorrow and then you get a 3-day weekend. It doesn't make sense for me to start like 20 minutes into the next section if it's going to be 4 days until we start it again. So you'll have some tonight, but not over the weekend. Yeah? So start with radicals. Oh, yeah, we did the regression thing. Cool. Just like with all the other monomials, because I don't have a bunch of other terms messing with it, I know that this stuff is just always going to be true. It just depends whether n, the index, is odd or even. If it's an even root, well, that's second commandment to domain, thou shalt not take even root of negatives. So I have to restrict the range on it to make sure that it's still a function. However, if it's an odd root, like if I said what is the 5th root of negative 32? What to the 5th makes 32? Close. Negative 2. Because I can write this as either 5th root of negative 1 to the 5th times 2 to the 5th, or I can write the 5th root of negative 2 to the 5th. In either case, the 5th root of negative 1 is negative 1. 5th root of 2 to the 5th is 2. 5th root of negative 2 to the 5th is negative 2. Okay, so because odd powers are cool with negatives, they have a domain and range of all real numbers. Whereas evens, if I tried to say what is the 4th root of negative 81, you break domain. You're trying to take an even root of a negative. Okay. So, blah, 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 I can look at a function and tell stuff about it. So we got, well, they're all kind of ugly. Because it's got fraction in it. And kids are afraid of fractions. I'd like you to graph this one and tell me all the stuff about it. Can you?
Yeah, because the thing up top, it's odd, so.
You sure about that with that compression up front, with the translation in there? It is not just A or B, because this one has transformations. Okay? Because it has transformations, we can't get away with that. Now, if you got no idea how to graph this, just dump it into Y1 and get some table. Just plot points by a table. They're all going to be ugly numbers. Wing it. As long as you can estimate two 1.6 on a graph, well, you can still graph it. Grid off. Second, format. Format's right above zoom.
Ew. Why? Oh, that was it.
Oh, it's a skinny mini, yeah. This is like, hey, dude, I got you a cheeseburger, but I accidentally sat on it the entire way home. It's squished. Or I was struggling trying to bring too many things in the house, and I slammed our bag of food in the door of the garage.
I slammed an ice cream sandwich in my It was all over like the pockets of the food, you know? Ew. And then I was trying to not shut the door so the food pushed it, and then I opened it. Mine said there's a hole.
There is not a hole. What's going to happen is, because it moves so sharply in the middle, to show the axes, sometimes it kind of cuts out the graph. Sometimes we have reached the point where we got to be smarter than the calculator with some of these graphs.
I know my window, my Y was negative 2.
Solve.
The X and Y intersect go to.
How do you find a y-intercept? Plug 0 in for x.
Or just go to second power.
It won't be a simplified radical answer.
She's like,
Oh yeah, if you want to find your x and y intercept, you got to do it real. Put a 0 in for x, solve for y. Put a 0 in for y, solve for x. Yep. I would say continuous from negative infinity to infinity. The interval along which it's continuous. Yep. We got domain, range, x-intercept, y-intercept. The limit of my function as x approaches. What else? And behavior, continuity, increase, decrease. One, 4, 7, 5, 4th, 5th, 64, 256, 1058, 75. Holy nads. Okay, so that's just never happened. Not on this graph. It's a really skinny mini. Because that's 5, 1, 1, 4, 4 to the 5th, 4, 4, 16, 64, 256, 10, 24, 1024, 1032 over 6. That's 100, 432. 172. The y value doesn't hit 1 until 172 for x, I think. Go to the table, do the ask feature. Plug in x is 172. See if my mental mojo's on. Okay. So it's not going to get above or below. It's not going to go past plus or minus 1 for a very, very long time. But it does have this odd root shape to it. It's just super squished. Okay? So, domain. Everybody allowed to that party. Range. Same. It's just going to take forever to get there. Okay? X-intercept. Set y is 0 times 4 fifth of it. That's going to be way out there, right? If y is 0, 754. Oh, yeah, 0, 0. Okay. 4/3. The transformation, that's right there in front of me. Yeah. If you make that a 0 times 4, 0 to the 5th is still 0. So you effectively get 6x minus 8 equals 0 and solve. Right? Add 8, divide by 6. Maybe? No? If I say 0 is 1/4 fifth root of 6x minus 8 times 4, it's still a 0. Take both sides to the 5th power, still 0. Add 8, divide by 6. X-intercept at 4/3. Okay. Y-intercept, put a 0 in for x. I'll get the 5th root of negative 8 over 4. You write it like that. There's nothing wrong with that. It's at 0, negative 5th root of 8 over 4. Right? Just shove a 0 in for x and then simplify the radical. Limit. As I go to negative infinity, what? But an odd root of a negative is always negative.
Oh, you just put it out.
Yep.
There. Okay.
As I head all the way to negative infinity, luckily I have an infinite amount of time to get there, we will go to negative infinity. As x approaches positive infinity, I will also go to positive infinity. It just takes an infinite amount of time to get there. Continuity. I never picked that pencil up. So continuous for all real numbers. And increase and decrease. Your pencil's always going up. Not very much, but it's going up. So negative infinity to infinity, never decreasing. Okay. I should be able to give you any function regardless how nasty it is. And I can graph by table, I can plug in zeros for x's and y's, I can test things, and I can figure out what is what with this function. Okay. So, that got a little sketchy. Again, If it got sketchy, we got to practice it. I would rather you practiced it more in class where you can be sure you're doing it right, talk to your neighbor, instead of here's one example, now do 3 of them on your homework. I would much rather get the practice in class. Speaking of, if you are not distracted, are we still sitting around that 15 to 20 minute mark for our homework? Or are we going 30 plus?
It depends on how many problems there are.
Never 15? 20 to 30? Over 30? How often is that happening? If you're not distracted. Like once every 4 lessons? 3? 5?
It just depends how well I get it.
Okay.
I understand the concept is a lot.
Yeah.
I don't ever want you to have to spend more than, even for pre-calc, even for an upper level class, 30 minutes on homework, too much. I want it less than that. So I just need to adjust the homework. Okay? Even if it's just do 1 of each example and call it good. Y'all got a life outside of school, go live it. I don't want you spending more than 30 minutes on this class. You see how you can get a shift on it? The transformation. I can pull a B value out and turn it into an A value. It's not a pretty one. It ain't pretty, but now I should know this thing shifts over to the right 8. Yes, no? Like, not 8, 2. 2. Because it's cubed. Okay, so blah, 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 I see a even radical. Even radicals with a positive coefficient are going to do something along the lines of this. You would just transform it. So this one, if I want to know where it starts because it doesn't have a vertical shift at all, I can just go straight to my x-intercept to actually start my domain. I will plug 0 in for y. Say if 0 is 1/2 4th root of 2x cubed minus 16 times 2, it's still a 0. To the 4th, it's still a 0. Add 16, divide by 2. I get x is 2. So if I have an x-intercept at 2, 0, and no vertical shift, nothing in the k spot, then I know my domain goes from 2 to infinity. When I plug that 2 in, I get a 0 out. So that means that's where my range starts. My range goes from 0 to infinity. So it's going to head off into the wild blue yonder, but it's going to have that ridiculous, ugly compression to it. So I'm just going to grab a calculator and plot by points. I don't even know what the points are, but I'm guessing you do because you press the buttons and I'm not pressing the buttons. Cool? Okay. Y-intercept? It never hit the y-axis. Well, I know as we head off to infinity, my limit is infinity. Do we remember what to do on the left side? As I approach 2 from the right side, it approaches 0. As I approach 2 from the right side. Continuity. This is what I mean by we want to state continuity in terms of the domain. On the domain, wasn't it always continuous? Like, I can't say there's infinite discontinuity back here because it doesn't exist, because infinite discontinuity involves going up to plus or minus infinity. It's just not there. So I will say it is continuous at 2 to infinity. It's continuous along its domain. Just, it doesn't exist over here. That doesn't mean that it's discontinuous. That means I didn't start moving my pencil until 2. Increase also from 2 to infinity, never decreasing. Okay. So even if the algebra part of it gets rough, I can handle it. You can always just plot points and then look at the graph. Okay. All the way back to Algebra 1. How do I undo squared? Square root. So how do I undo square root? Squared. Okay. This is from all the way back in Algebra 1 was the first time we saw it. We hit it again in Algebra 2. If I'm going to go squaring things, you probably don't want to square it with a binomial. Because then you would have the radicand squared, 2 of the radicand, and then a constant. So let's put that 2 on the other side. Then I'm in good shape. If I square both sides, whenever I square root, cancel town, I just get 100 minus 2x. On the other side, 12? Oh. What do I get on the left? No freshman math. 4x squared plus 8x plus 4. If you don't remember the trick, square the first term, square the second term, multiply and double, because you're going to have 2 of them. If I take 2x plus 2 by 2x plus 2, or you know what? Let's go biology on it. You remember that?
Yes.
Some kids just love this. Other kids hate it.
I can't do it any other way. I can't do it.
Right? It works. But if it's not your jam, don't do it. Okay, how about, do you remember old school? What if I said, what is, you remember that?
No. I literally can't. Oh wait,
Multiply.
Yeah. Oh yeah.
1 times 2 is 2. 1 times 1 is 1. 0 is a placeholder, because I moved over to the next digit. 2 by 2 is 4. 2 by 1 is 2. And then combine like terms. Well, can't I do 2x plus 2, 2x plus 2, like this? And say 2 by 2 is 4. 2 by 2x is 4x. 0 as a placeholder. 2 by 2x is 4x. 2x by 2x is 4x squared. Combine like terms. If you're so, you have been distributing since you first learned multi-digit multiplication. Ever since you first had to do in elementary school 36 times 105. You've been doing distribution of polynomials. Because you're grouping by place value when you say 484. Isn't this the hundreds place value, the tens place value, the ones? Isn't that 10 to the second, 10 to the first, 10 to the 0? Just like x to the 0, x to the first, x to the second. Place values are descending order of polynomials. X squared is in the 10 squared hundreds place value. Just saying, you've been doing it this whole time. But anyway, I get here, now what? What type of function am I looking at? Quadratic. So, if it's quadratic, solve it like a quadratic. Everyone to one side of the bus. 4x squared plus 20x minus 96. Since I can divide everything by 4, make my life easier. Because 0 divided by 4 is still 0. So x squared plus 5x minus 19. Right? Not. Right? By 4. Oh, 24. I'm thinking by 5. And that just, it doesn't work because that's a 96, not a 95. Okay, and factors nicely into x plus 8, x minus 3. What? Divide each by 4. Factors of negative 24 that add up to 5 are 8 and negative 3 respectively. Set both equal to 0. Say x is negative 8 and positive 3. Hi.
This might be a stupid question, but do you have, so when you factor out the 4, do you have to keep it on the outside? Like,
Yeah, that's what I was
Okay,
thinking about.
if I had done instead 4 times x squared plus 5x minus 24 is 0, that would be 4 by x plus 8, x minus 3 equals 0. Remember we set each thing equal to 0, right? Well, if I say x plus 8 is 0, x minus 3 is 0, 4 equals 0. No, it doesn't.
Yeah, because if it's x squared, you only have 2x. If it's x cubed, you have
Okay.
That's what I was asking when I was like,
Because effectively what you have here is 4 times something equals 0. What has to be true about A and B? One of them's got to be 0, right? That's the only way you're going to make 0. The 4 will not affect that. It's still what's making these two 0, because 4 is constant. So, no, you don't have to factor it out. If you're trying to work with the graph, you want to factor it out and leave it there, because now that's the amplitude of it. That's the vertical shift. But if you're just trying to find zeros, you can divide it and get it out of there. Like, it is possible for you to have this versus this as parabolas. One of them's 4 times taller than the other, but they have the same x-intercepts. They have the same zeros. Okay, so if you're working with the graph, factor it out and leave it there. If you're just solving for zeros, get rid of it. I'm not done. Check that answer. We have the 4 commandments of domain. Well, we know the 3 commandments of domain. And the second one is thou shalt not take even root of negatives. Since my original equation has an even radical in it, I have to check because there was the potential to break math. So if I jam a 3 in there, I got 6, 36, 64, square root of that's 8, 8 minus 6, I get 6 equals 6. Yay. But if I put in a negative 8, get 196, square root of 196 is 14, 14 minus 2 is 12. Last time I checked, did not equal negative 16. Make a note to yourself. If your original problem is an even radical, you have to check your answer because there is the potential to break math, to violate the second commandment of domain. It's kind of like the whole, love thy neighbor. Well, what if I live alone in the woods? All right, you're good. Okay, if it's an even radical, you need to check because there is the potential to break math. All right, this one, cube root. So I don't need to check it because there's not a potential to break math. So I undo radicals by whatever the exponent is, but I can't do the exponent if, okay, get that 14 down there first. Third root of x minus 5 squared is now 36. 36 to the third. That's what I heard?
Yep.
Okay. Now what? I have to square root to undo squared. Oh, there's an easier way. What? Yes, Paul's dead on here. I put that square root there. So it's going to be plus or minus. What is square root of big chunky over there? It should be 216. Okay. And then I add 5 to both a positive and negative 216. So 5 plus 216 is 221. 5 minus 216 is negative 211.
No. 11. Oh.
Yeah,
Oh,
yeah,
yes.
yeah, you're right.
No,
you're
you're
right.
right, because it's...
Don't mess with me. I am not caffeinated enough for this. I'm going to start taking brownie points away. You know what? I'm going to bring back the list of shame. Well, that's how it started.
Wait, so we have to make you brownie?
You have to bring in food for the class. The way that the list of shame started was I had the only class to ever get 3 trays of brownies off me in one semester. Had the high flyers. There was like 6 girls who sat right there, and I called them my council of ladies. And there was like 5 of them who were just super get it. And then there was that redhead in the back that was like the class attorney, and she would argue for the brownie points. Well, she would argue and say, well, no, that's a 5. No, that's a negative. No, that's not negative. What are you wrong? And I would change it just out of impulse. And then they would try to call brownie point on me because I changed it to the wrong thing. So finally one day I was like, no, we ain't doing this. And then I wrote Morgan up there and said, every time you do that, it's a point on you, not me. You hit 5, you screwed me up, you bring in food, not me. And it kind of evolved over the years, and eventually there was a list of like 20 kids up there. And it was like, when this kid argues incorrectly, when this kid says the thing that makes everyone in the room facepalm, when this kid...
Bro, what?
when this kid interrupts and gets us completely off track like we are right now. When this kid, and they would get their point of shame. And when you hit 5, you bring in food. Yeah.
So why do you have to square root it? Couldn't you just solve it?
Okay. Now, let's come back to math. Okay. Owen's in the other class. Holden says, when I'm right here, is there a different way to write this?
Oh, yeah.
Remember rational exponents? Okay. Didn't you notice that we had to cube and then square root? Well, if I cubed it and then I square rooted it, isn't that the same as to the 3 halves? Boom. Okay. But there's a caveat with this. You got to be careful. What is over 2 as a radical? Square root. And you might forget to put the plus or minus on there if you don't actually see the square root. So if that denominator is even, you still have to plus or minus. Now the nice part about this is you don't have to touch the calculator because I can take it in pieces. This is 36 to the third times 1/2, right? 3 times 1/2 is 3/2. Multiplication is commutative. That's 36 to the 1/2 to the third, which I can call 36 to the 1/2 to the third. Well, what is the square root of 36? 6. What is 6 cubed? 216. Okay. So you can actually do this by mental math because you know what your perfect squares and cubes are without touching the calculator. So it's just a different way to do it. It's a more efficient way. Now, if I always solve these by isolating the radical, how do I get through it when I can't isolate the radical because there's 2 of them? Unfortunately, we can't because they're not the same radicand. And they're also being adding and subtracting. If it was multiplying radicals, okay, I can. But there's a sum or a difference, so I can't. I can square it, it's just going to be ugly. Okay? If I square both sides, remember that this is 5 minus square root of 15 minus x times 5 minus square root of 15 minus x. 5 by 5 is 25.
Wait, is this the only way you can do it?
5 by, well, you can square with the shortcut. That's what I'm headed to.
I just didn't know if you had it.
Oh. 5 by this, I'll have a negative 5 root of 15 minus x. Negative root of 15 minus x times 5 is another negative 5 root of 15 minus x, which is minus 10 root of 15 minus x. And negative square root times negative square root is positive that radicand.
If you just subtract the x over x minus 2 to the other side, would that make it easier?
But it won't come in here. This is a separate radical. This radical can't shove itself into that radical by subtraction. They're not like terms. But they're not being multiplied. They're being subtracted. You just got to deal with it. Okay? Now, I can still use the squaring a binomial trick. Square this, square this, multiply these two, and double it. That trick is still in effect. It's just uglier. On the other side, I just got x minus 2.
And then wouldn't you have to square it again?
You got a double dose. Because there's 2 different radicals, you square once to eliminate one of them, then isolate the radical and square again.
I think we should simplify it.
Before we do that, how about we turn this into x minus 2 is 40 minus x minus 10 root of 15 minus x. Bring 40 over, add x, I can divide by negative 10, but do you want to square with a fraction in play? I can divide by 2 just to make things a little smaller. Call it x minus 21 is negative 5 root of 15 minus x. Okay, side quest. What happens when I do 3 squared is 7 squared? Completely unrelated to this. I'm just asking, how do I do that? right? Because I'll have 3 square root of 7 times 3 square root of 7. I'm squaring the outside and squaring the inside. So I can do that here. If I don't want to divide by that -5 and have to deal with squaring fractions, I can just square this side, x squared minus 42x plus 441. Square it, multiply and double. Square it, square it. Right? Square outside, square inside. Distribute, throw everyone on one side, take care of your quadratic. (25/15) is 250, 125, 375? Minus 25x. Everyone to one side of the bus. U. X squared. Why can't I do basic arithmetic, but I can do that? 17? Negative 17? Subtract 25, 41, 66. Oh yeah, because that'll, okay. Because that factors into x minus 6, x minus 11. Factors of 66, add up to 17, or negative 17.
No, I just made this up.
X is 6 and 11. So you got to square it once, so you can get rid of one of the radicals. Isolate the one that's left over, square it again. Okay? Yeah, you do, because the original has even radicals. Original has even radicals, so I have to check. I might have broken math. Shove a 6 in there. 6 minus 2, 4, square root of 4, 2, 7, 5, 6, 9, 3, 5 minus 3, 2, check. 11, 2, 9, 3, 5, 5, 4, 5 minus 2, 3. Yeah, they both work. Cool. Who do what? That's a dangerous question. Okay, one, I would not take it. I would freak out because GIFs actually make me very uncomfortable. Yes.
What if they just like leave it in your classroom?
Then I'm going to panic. Because I know I didn't buy it, so that means either...
What if they put conferences or something you would not be happy if I bought you like coffee?
I hate coffee to begin with, but same. I am making an attempt to get rid of all pop right now, so that would just be like devil temptress. I would put it in the cabinet and I would give it to my Game Club kids. Anyway. You want to fight, Maddie?
Can we say hi to Andy?
You can break the smart board.
Hi, Andy. Yeah, I think he's awesome.
So anyway, do this, please. Yeah.
We're doing all three?
All three. Move it over, square both sides. Solve quadratic. Move it over, get rid of the cube root. Solve. Square both sides, get ugly mess, clean it up, square it again. Uh-huh.
Yeah, it should be -18.
I'd have fun with it in Game Club.
Oh, you know, like the Orby. Yeah.
I feel
The
like
Orby
your
guns or
sense
whatever. Shoot like their little
where they go
like gel beads.
they're wet.
I don't think
and
you would like it.
You mean paintball?
Yeah, they don't paintballs.
Paintballs hurt. My
They're
brother shot me in the
slimy.
back of the head with one. Yeah.
How close?
You don't. I don't really remember.
I saw this
I'm
kid at
pretty
camp
young.
like hold the paint gun here and then shoot himself in the shoulder as like a battle scar, and leave like this massive welt that stuck up like an inch.
So anyway, let's do math.
It's crazy.
What's your favorite pizza, Lauren? I'm doing that. I'm just wondering.
The kind that I bought myself.
I was just like voice the question. Because it's just like, no, you're down the hole.
I don't think you like it.
I'm 100 pounds. I feel flying into that part more than ever.
Why are you staring at me when you said?
So then I didn't.
Three x minus 1. And 3, 9 out, 2 minus 2. X minus 1, x squared. Minus 2x plus 1. Minus 2x plus 1. Minus 2x plus 1, x squared minus 4x. Plus 3 is negative 3 and negative 1. 3 and 1. Oh yeah, because it's minus minus. So 3 and 1. 3, 18, 54, 54, 8, 36. Square root of 6 is 6 is 9. 3 works. 1. Got 1, 4, 64, 56, 4, 14. 5x squared. Squared 14x. 49. 40.
So you did the same thing I did.
38. 49 minus 9 is 40.
How did you get your name?
40, 38.
I said it right.
X squared. No. Oh, x plus 7. X, 2x. 2x minus 2, 2x minus 4. X minus 2. X squared minus 4x plus 4. squared minus 4x. X squared minus 4x plus 4. X squared plus 3x plus 2. X is x plus 3 minus 2. Oh, we lost it. Plus 7, 9. X minus 2. X minus 4. 2x minus 4. 2 of those is x minus 2. X minus 2 is x squared minus 4x plus 4x squared minus 3x plus 2. X minus 2, x minus 1. There it is. So 1 and 2.
What's 6 squared root 2 times 6 squared root
1 and 2. 1 gets you square root.
What is it? You think it's 12? 12.
I lost it on my check. Does the other one work? I lost it on my check on the second one.
I got 2. 2 and 1. I got 2 and a half. But I didn't check.
I don't know. I think it's 36.
Oh. Do you want to see what I did?
Dude, I totally messed up.
36. Then print inside of print and key.
When I
Yeah.
got off, I was like, oh, you just double check my work.
I got 2 and 2 and.
He said he lost the second thing.
I lost the second one.
I got 2 and negative 7.
Okay.
I'm pretty sure.
This is why we never show you how to use a graphing calculator in Algebra 1. Screw.
I did both times.
You're just gonna find me.
Yeah.
Hey, he's kind of faster.
What?
Yeah, negative 7.
Come on, Frank. Ruh-roh. Do they both not work? No, 2 works. Okay.
Try it out.
All right, let's actually do them for real. I'm just trying to wake up my brain. So, okay. Isolate the radical. Who squared right here? Who factored out the 3 and then squared? Because
Oh, that makes it much easier.
now, if you don't, you're just going to end up dividing by 3 later. Like it's no different. X squared minus 2x plus 1 is 2x minus 2. Everything over to one side. X squared minus 4x plus 3. Didn't you have, if you didn't do all of that, 3x squared minus 12x plus 9?
Yep.
And then you just have to reduce it down anyway. So, okay, so 9 times, oh yeah, because it's squared.
They were all in sync. Did you hear that?
Yes. Come play with us, Danny. So x is 3 and 1.
It's so good.
Check them both. If I jam in a 3, I do get a 9 equals 9. If I jam in a 1, I do get a 3 equals 3. These ones, personally, I think are a lot easier.
Yeah, that one was really easy.
Subtract, cube, subtract, divide. It's a cube root, so you don't need to check because you can't break math. I mean, unless you just suck, but like. No.
I'm gonna prove that I can.
Square both sides. That's why I lost it. I was thinking there was a 2 there instead of a 6. Okay. When I square this, don't try to mess with its signs. Right? A radicand squared, or a radical squared is just the radicand. So it's just that. Don't mess with its signs. Everyone to one side of the bus. Get 2x. That's 11. Subtract minus 4 is 6. Square root of 2 minus x. If I can divide to make my life easier, I will. No, you'd just end up reducing later. It's just, do I clean up now or do I clean up later? I still got to clean it up, right? Square both sides. X squared minus 4x plus 4 is 9 by 2 minus x, which is 18 minus 9x. And everyone to one side again. X squared plus 5x minus 14 is 0. Getting x plus 7, x minus 2. So we say x is negative 7 and 2. And negative 7 will work. When a 0 equals, nope, because that won't be negative. Womp womp.
I did it right. I'm pretty proud of
Look up the right answer.
I really love that one.
I
I
actually kind
did
of
the
understand.
X-rays to forgot to.
I know exactly what it is.
I got messed up somewhere else.
I'm proud of myself.
Good. So, square it to isolate or to get rid of one radical. Oh wait, there's still one there. Blow it up again. Okay? Dun, 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 dun.
Do it.
Dun dun. Okay, the graphs we spent enough time on. Those.
So just cross that out. Please let us be done. We've got it. We've got it.
No,
You're good. Can we just give thumbs up? Like,
We've had so much practice. I think we're
Are we actually good, or are we trying to avoid it because we don't get it?
no,
Thank you. Double pinky promise.
Oh, good.
my God.
Oh.
You were a chaotic evil there. This is not chaotic evil. This is Master Oogway laughing and chuckling while the student learns.
It's like while the panda's feeding himself up.
Yeah.
I totally do.
6 x plus 12 minus 4x minus 9.
No, you just squared like a freshman, Haas.
Look at that. I'm getting there.
I would strongly recommend that you go ahead and put one of those radicals on the other side. Because otherwise, you cannot just square it like it is right now and everything is fine. Your middle term would be 2 radical times radicals.
We're not getting the other thing. I'm just asking for room for writing. Stop. No, I'm not.
I think we are good on the other ones. It's the double radicals that we're having trouble with.
I just needed more room to write, so I wanted to make sure that.
Okay. Be not afraid. Do or do not.
I did it.
It's 9:40. You should pack up now.
I don't think so. Move the radical to the other side. Square both sides.
That's cool.
Make life easier if you can.
It's your rainbow. It's cool.
Check them both. -2 does not. -2, 0, minus 5, -2, 0, 1, minus 5. So -1 equals 1, so that one's out. 4, 6, 24, 36, 6, 4, 16, 9, 25, minus 1. Yep. Randomly, I've asked this question in the past. Some kids care, some kids don't. Is it easier to follow if I keep it in color order like that?
Yeah. I like it. It's rainbow.
Well, not just, yay, it's pretty, but
No, yeah.
for some kids, switching from yellow to purple to green to red is jarring.
I mean, it looks nice.
Okay. It matters because you can see the steps, but
I'm that kid.